There's a moment almost every new parent has experienced, usually sometime in the first few weeks, usually late at night. You've finally gotten the baby calm. They're not crying, not feeding, not sleeping. They're just lying there, completely still, eyes wide open, staring at the corner of the ceiling like something is there. You look, nothing. You look back at them, they're still locked onto it, unblinking, completely focused. And in that moment, in that quiet house at 2 in the morning, some part of your brain that you thought you'd outgrown asks the question you'd never say out loud. What if they can see something I can't? Billions of people across thousands of years of human history have asked that same question, and the answer that folklore, religion, and tradition settled on is fascinating. But science recently came up with a different answer, and the scientific answer is, if anything, stranger than the supernatural one. Because what's actually happening inside a newborn's brain when they stare at that empty corner isn't mystical. It's something far more unsettling. It's construction. Active, chaotic, high-stakes construction, and understanding it will completely change how you see those long, silent, unblinking stares. Let's start with what we actually know about a newborn's vision, because it's not what most people think. When a baby is born, their eyes work. The hardware is functional, but the software, the brain's ability to interpret what the eyes are sending, is barely installed. A newborn has vision roughly equivalent to 24/100ths. That's the legal threshold for blindness in most countries. At that resolution, your face from 3 feet away is a pale blur with 2 dark smudges where your eyes should be. The world is not a picture, it's a fog. But here's where it gets interesting. Inside that fog, there are certain things the newborn brain is specifically wired to detect, even before it can detect almost anything else. Sharp contrast, edges, the hard boundary where one surface ends and another begins. This isn't an accident. It's the result of 60 years of neuroscience that traces back to one of the most important experiments ever run on the visual system. In the late 1950s, David Hubel and Torsten Wiesel at Harvard Medical School inserted microelectrodes directly into the visual cortices of cats and began showing them different shapes and stimuli to see which patterns triggered neural firing. What they found was that individual neurons in the brain's primary visual cortex didn't respond to general light or color. They responded to edges. Specific orientations of contrast boundaries would cause specific neurons to fire intensely, while the same neuron would sit silent in response to almost everything else. The brain is not a camera, it's an edge detector. And that discovery was so fundamental to understanding how we see that it won Hubel and Wiesel the Nobel Prize in 1981. Now apply that to a newborn in a room. Most things in an infant's visual environment are relatively low contrast. Skin, fabric, painted walls, soft light. But a corner, specifically a ceiling wall junction in a normally lit room, is one of the highest contrast geometric structures the visual system is ever going to encounter. 2 flat planes meeting at a precise angle, each lit differently, creating a hard edge that runs the full width of the room. To an edge-detecting brain that can barely process anything else, that corner is essentially screaming. It is the loudest visual thing in the room. This is why babies don't stare at empty air. They stare at corners, specific corners, the ones where the contrast is sharpest, where the light hits most directly, where the geometry is clearest. It looks like they're focused on nothing. They're actually focused on the most visually salient structure in their entire environment. The adults in the room have learned to ignore it. The infant hasn't. To them, that corner isn't background, it's a spotlight. But that's only the first layer. Because even if you accept that corners are visually interesting to infants, it doesn't fully explain the intensity of the stare, the unblinking, locked-in quality that makes it feel intentional, like they're watching something move. And for that explanation, you have to go deeper into the newborn brain, into a phenomenon that neuroscientists are still actively trying to understand, called retinal waves. Before a baby is born, before their eyes have ever encountered a single photon of actual light, their visual system is already active. The retina spontaneously generates waves of neural activity that travel through the optic nerve into the developing visual cortex. These aren't responses to anything external, they're internally generated, like the visual system running test patterns on itself before the factory opens. Researchers believe this is how the visual cortex wires itself prior to birth. The system practices seeing before it has anything to see. After birth, this spontaneous internal activity doesn't immediately stop. It continues for weeks, gradually phasing out as external input takes over. And here's the critical part. Newborns in the early weeks don't have a clean separation between being awake and being asleep. Adults cycle through distinct brain states. Infants, particularly in the first 6 to 8 weeks, exist in a fluid continuum between REM sleep, drowsy wakefulness, and alert wakefulness. And during those transitional states, the internally generated visual activity can overlap with what the eyes are actually receiving. What does that mean in practice? It means there are moments, brief windows, where a newborn's visual cortex is processing something that isn't entirely coming from the outside world. Not a hallucination in the clinical sense, something more like a double exposure. External edges and internal patterns layered on top of each other in a visual system that doesn't yet know how to separate them cleanly. And if you thought that was strange, what comes next reshapes it entirely. The infant brain isn't just processing edges differently than an adult brain, it's also face matching differently. In adults, the fusiform face area, a region of the temporal cortex specialized for recognizing human faces, is highly calibrated. It knows what a face looks like, and it mostly ignores things that aren't faces. In infants, that calibration hasn't happened yet. The fusiform face area is active and eager, but it has a hair trigger. It responds to face-like patterns in visual noise. 2 dots above a curved line, light and shadow arranged roughly like eyes and a mouth. Any configuration that passes the loosest possible test for might be a face gets flagged. Researchers call this the adult version of pareidolia, seeing faces in clouds, in wood grain, in the shadows on your ceiling at night. In infants, this isn't a quirk, it's the default. The face detection system is running in its broadest, most inclusive mode, searching everything for something that might be human. And textured surfaces, shadows, the play of light on an irregular ceiling, these environments are rich with false positives. So now, put it all together. You have a visual system optimized to detect edges that finds the ceiling corner visually overwhelming. You have an internally generated activity layer that can blend with external input in transitional sleep states. And you have a hyperactive face detection system that is flagging patterns in the surrounding environment that adults have learned to screen out entirely. The infant isn't seeing something you can't, because their brain is running a fundamentally different version of visual processing software, one that is wider, louder, less filtered, and capturing inputs that your optimized adult brain discarded years ago. And before we talk about what this means, I need to tell you about the cultural layer of this story, because it's too consistent to ignore. Across virtually every culture that has ever kept records or oral tradition, the image of an infant staring at empty space carries the same meaning. In Japanese tradition, it's said that newborns can see the spirits of ancestors who gather to welcome them. In parts of West Africa, infants who stare at nothing are believed to be in conversation with the divine, not yet fully departed from the world they came from. In Scandinavian folklore, the cradle had to be positioned carefully so a child's gaze didn't get trapped by certain corners where spirits were believed to linger. Caribbean traditions hold that very young babies can see the souls of the recently dead. Indigenous cultures across North and South America describe infants as existing temporarily between worlds, 1 foot in the spiritual plane, 1 foot in the physical. These traditions are separated by oceans, by centuries, by every possible cultural variable, and they arrived at the same image, the infant staring at what adults cannot perceive. Anthropologists who study this convergence argue that it's not coincidence, it's pattern recognition. Across thousands of generations, human communities observed the same behavior in their youngest members and constructed explanations that made sense within their worldview. The behavior was real. What varied was the framework. What folklore called ancestral presence, neuroscience now calls cortical edge detection and fusiform hyperactivation and retinal wave bleed-through. Different languages for the same observation. But here's the part that doesn't fully resolve. Even with everything we know, even with the Hubel and Wiesel research and the retinal wave data and the fusiform hyperactivity literature, researchers at the Infant Cognition Center will tell you something important. We can explain why the visual system makes corners salient. We can explain the internal activity patterns. We can explain the face detection overdrive. What we cannot fully explain yet is the purposefulness, the sense that the infant isn't just detecting something, but tracking it, following it, responding to it. Some infants make sounds during these episodes. Some smile. The eyes move with the slow deliberateness of something watching rather than something simply registering. That gap between what the visual neuroscience explains and what the behavior looks like is still open. Active labs are still working in it.
So the next time you're standing in a quiet room and you watch a baby lock onto an empty corner, you now have two things happening simultaneously in your mind. The scientific answer, which tells you that what they're responding to is real, geometrically real, neurologically real, a symphony of edge detection and spontaneous cortical activity and hyperactive pattern matching that no adult brain could replicate. And the older question, the one that every culture in human history has asked while watching the same scene, which is whether the scientific explanation is the whole explanation, or just the part of the explanation we've been able to measure so far. Every generation of scientists has discovered that the previous generation's complete picture had something missing. The humility of good neuroscience isn't just knowing what we've found, it's knowing how to hold what we haven't found yet. Your baby isn't staring at nothing. They never were. The question was never whether something was there. The question was what kind of something it is. And if you want to keep following that thread, the next video covers what's actually happening in a baby's brain during those first genuine smiles. Because it's not happiness. Not yet. What it actually is will surprise you.